for the last 4 hours. There's nothing in there to steal. Oh, it'll be fine. All right. So, for the triangle midpoint theorem, what we've done is we've found the midpoints of these two legs right here. And what the triangle midpoint theorem says is that if I connect those two midpoints, which I will do right now, that this line segment, let's give them some names. So let's say this is not 17-point font because that is a bit ridiculous. How about 10? So I'm going to call this point A, this point B, this point is going to be C, and I'm going to call this one X, and I'm going to call this one Z just because it's fun. All right. So what the triangle midpoint theorem says is that if I connect the two midpoints, that I will end up with a line segment that is parallel with the line segment of the triangle that we did not connect the midpoints to. But that's not all, folks. That's not all. The triangle midpoint theorem also says that line segment XY, and you can barely read that, so I'll do this in a different color. It says line segment XY, I really do want to have X is equal to 1/2 line segment AC. So not only do we get a parallel line segment, we get a line segment that is exactly half the opposite line segment. Wow. Now, not only that, but we also have a cool situation where we have two similar triangles. So we know that triangle XBZ is similar to triangle ABC. Now, what is the scale factor to go from triangle XBZ? Times 2. How many times larger is the area?
4.
It is 4 times larger. And I know that's true because if I'm going to erase a bunch of stuff right here. So I'm going to move these construction lines for a moment. So if I were to find the midpoint of AC, so let's say for the moment that midpoint AC is right here. It's pretty close. If I connect this midpoint, let's go with, you can see the 4 self-similar triangles that make up the entire ABC triangle. So we have a scale factor of 2, and the area is, again, 4 times smaller, or 4 times bigger, depending on which direction you're moving. So that is the triangle midpoint theorem. So we have to remember that we are getting a line segment that is parallel, and it is 1/2 the length of the opposite side length, right? Okay, so let's take a look at how we can use this in application. All right, so for example 1, vertices of triangle X, Y, and Z are listed. M and N are the midpoints of X, of line segment XZ and line segment YZ. Show that M and N are parallel to XY and that MN is half XY. So what's the first thing we really want to do with this?
Label the points.
We want to label the points and put them on a grid. Let's put them directly on a grid. Because I have a feeling we're going to have to deal with some, I don't know, distance formula maybe?
Wait, how are we supposed to put on a grid though?
Okay, so we're proving that the slopes are the same. So what is the slope of xy?
Negative 2/3. Right?
I don't know.
Wait.
I asked you.
Oh, I was like, how did she know that?
Wait, because I'm opening my head.
2 minus 8.
I can't. That's 5/3, I think.
Wait.
I'm not sure though.
So let's count. So 1. I shouldn't be the only one. 2.
3,
Thank you.
4, 5.
Okay. How far down did we go here?
3.
Okay, negative 3.
Wait, so negative 3/5.
So is that the same for this?
Let's say yes.
Let's say, no, we can't just say yes. We have to prove it.
Wait.
So how far over, how far down?
5, 1. No, it's 5 and 4.
Are you sure about that?
5 and 4.
What? It's 3, Claudia.
No,
It's
it's
3.
down, so it's negative 3/5 again. So they're the same.
So, right.
Wrong.
Yeah, so we end up with the same slope. I'm sorry, that's the negative right here. So we've proven that the two lines are parallel. Okay. What do we need to do to prove
That's
that?
called the slope formula, right?
Excuse me?
That's called the slope formula, right?
Yeah. Well, rise over run. Yeah.
Is that it?
Well, we've proven that the lines are parallel. Now we have to prove that mn is half of xy, is equal to 1/2 of xy. So how do we do that?
Distance formula?
The distance formula. Now, the other way that I would consider doing that is using what you know about slope. Notice how 2 of these,
Wait, so is the hypotenuse 4 is the actual triangle?
the hypotenuse,
Or the slope triangles?
no, because it's 3, so 3 squared is
Oh.
9 plus 5 squared, 25. So you get 9 plus 25, which is, what, 34? So it's the square root of 34.
Okay.
And the square root of 68.
68.
So how do
Wait,
you,
so Mr. Frank,
yeah.
this is completely unrelated, but wouldn't that mean that that triangle MN?
Avery, what was your question?
Doesn't it mean that the figures are similar with the scale factor of 2, because it takes 2 5/3 slope triangles for x to y, and it only takes 1 for m to n?
Yes, so the scale factor go from xmn to, to the scale factor go from zmn to zxy would be 2, and it'd be 1/2 going the other way.
Oh, cool.
All right, so let's go ahead and try example 2. So what is the measure of
We
line?
finished the proof already?
Yeah.
Wait, no, we moved through the distance, didn't we?
Well, Claire and I did the distance.
That was quick.
Well, it doesn't take that long. Shh. So notice how the slope triangle also doubles as a Pythagorean theorem triangle, a right triangle. So what is 3 squared?
9. 9.
What's 5 squared?
25.
So 9 plus 25 is?
24. 24, 34.
34. So line segment MN has a scale, or has a length of square root of 34. So what about this one right here? So we so what's the height of this triangle?
Is it 6, right?
6.
6 by 10.
6 by 10.
And then, oh, okay, now I get it.
That's a chonkiest triangle.
Whose house is that?
This house?
Yeah.
I found it on the internet. I just looked up A-frame house because they're called A-frame houses. All right, so for question B, find the measure of BD and the angle measurement of angle CBD.
Didn't you give us
6.2.
PD?
I was gonna say 6.2. That's what it looks like.
So BD is 6.2.
C.
That's nice.
Hey, thanks.
Anytime.
Wait, so we know.
I appreciate it.
So the measure of angle FGB is 26. That's
Oh,
what it
you know
says.
what? Okay, so actually, you know what? Let's find the measurement. So the measure that I really want is FD. FD. Yeah.
FD.
And let's find the measurement of Yeah, we're still looking for the measurement of CBD.
Oh, dang it.
Let's cross it out.
All right. Okay, so, well, that's 6.2 and this is 6.2. Sorry.
Oh, it says the whole thing's 17. Okay. Wait, we're looking. FD is gonna be half of 17.
Wait,
Right?
no, never mind.
So
Wait, you have
8.5. C.
Wait.
This.
We're fine FD, right?
Yes.
CBD.
Wait, so is it,
Wait, what was
18.5? Is it 18.5?
I got 8.5.
So why?
Sorry, 8.5.
And so why would it be
Oh,
eight?
it's
Why would it be 8.5?
because it's half of 17.
Right, because it's half of 17.
Wait, would the measure of CBD also be 26 because it's similar?
Mm-hmm. Because they're similar, right?
Wait, so how do we find the CBD?
Yeah. Wait, so the measure of AD is 12.4, right?
Oh, we need to find A.
Mr. Frankie?
Yes.
So the measure of AE is 12.4, right? Because if that's 6.2, and since the triangles are similar, cause then wouldn't it be that, yeah.
Yeah, that's exactly right.
Yeah!
Wait, so how do we find the angle?
Because the triangles are similar, the angle's the same as the angle's 26.
Claudia, were you able to hear that okay?